Hello out there. Welcome back to Chapter 13. This is the fifth part of this series. There are a lot of these because I try to keep them less than 10 minutes so you can go and look at specific things. In this one, though, we're going to actually continue doing some concentration calculations. And what we're going to do is we're going to give you a set of information, and then you're going to calculate concentrations 5 different ways by using the information that you're given, and then also by knowing what other information you're going to have to need. All right, so if you recall, when we were doing molarity, we talked about the fact that you needed to know the molar mass, right? So that's one thing with these. If it's molarity or molality or mole fraction, any of these things, you know you're going to have to be able to figure out what the moles are. So it's probably a good idea when you first get to this. You've got 17.2 grams of ethylene glycol, which is C2H6O2. And then the formula weight of that you should be able to calculate very easily. There's 2 C's, 6 H's, and 2 O's. And so when you add that molar mass up, you should get about 62 grams per mole. All right, that's of the C2H6O2. It tells us that the water, which is the solvent, you have 0.500 kilograms of water. You have a final volume of 515 milliliters, and then it wants you to calculate these different molality on this page. All right, so one thing that I'm going to need to know is how many moles there are. So I'm going to go ahead and do that in my inventory over here, because I can do that very easily by saying I have 17.2 grams of ethylene glycol times 1 mole is 62 grams. And so when I do that calculation, I'm going to have 0.277 moles. And that just might save me some time if I do that later. The formula weight of the water, because that is my solvent, is 18 grams per mole, and I've got 500 grams because I've got 0.500 kilograms. So 500 grams times 1 mole is 18 grams. Gives me 27.8 moles of water. That's important because I may have to know total moles. Okay? All right. So the first one I've got to calculate is molarity. So when I see that, I know that I'm going to need my answer in moles over liters. So I'm going to go to my information, and this is moles of ethylene glycol per liter of solution. And so it told me that I had I calculated my moles of 0.277 moles of the ethylene glycol. And then how many liters did I have? Oh, I've got 515 milliliters. So 515 milliliters times 1 liter over 1,000 milliliters equals 0.515. So over 0.515 liters. And that gives me what I need to calculate this, and so my molarity is 0.539. That's moles per liter or 0.539 molar, because the big M is just an abbreviation for the 0.539. The next one is molality, and molality is moles of solute per kilogram of solvent. So I look over and I've got, again, the same number of moles. So I've got 0.277 moles. And then it's per kilogram of solvent. And it told me that it had 0.5 kilograms of water. So divided by 0.5 kilograms of your solvent. And that's going to give me 0.555 molal. So I'm using different parts of this, but all I'm doing is I'm looking and seeing what that unit needs to be, and then I'm going over here and I'm finding that information, and then I'm plugging it in. All right, so if you didn't multiply out and figure out how many moles you had at the beginning, you could just do the actual mole calculation of you could say you had the 17.2 grams in the 0.515 liters, and then you could have multiplied it by 1 mole over the 62 grams to get your answer that way. So I like to do it at the beginning and see everything that I have. If you forget something, that's okay. When you realize you need it, you can just go back and do it. Okay, so I may go back and forth a little bit on here since I've already written this. I'm going to remind myself I had 0.277 moles of the C2H6O2, and I had 27.8 moles of water. And for a total, did I do the total moles? So total moles is going to be those added together. Which should be 28.1 moles total. And as far as, and then mass, I had 17.6 grams of the C2H6O2, and I had 500 grams, because I had 0.5 kilograms, right, of water. And I'll show you why I did it that way in just a minute. All right, so percent by mass is grams per 100 grams, right? So in order to calculate that, I'm going to need to do the grams divided by total grams times 100. So I have 17.6 grams of the ethylene glycol, and then total grams I've got 17.6 plus 500 grams of water. So I'm just leaving it in grams because it needs to be grams divided by grams. So when I do it that way, then I'm going to multiply that by 100, and that's going to give me 3.33% by mass, because both of those are in mass. You can do it different ways depending on how it needs to be calculated. Okay, then the mole fraction. In the mole fraction, I know that I have 0.277 moles of the C2H6O2 divided by the total moles, which was 0.277 plus 27.8, because I have to have the moles of the water and the moles of the ethylene glycol. And I don't multiply that by 100 because this is a mole fraction, which is not times 100. So that is going to, and these will be small numbers usually, 0.00986. And then the mole percent is, and this is like, that's what that, remember that thing that looked like C2H6O2? The mole fraction times 100 is the mole percent. So, so 0.00986 times 100 is going to give me 0.986%. So I know I kind of went through those a little quick, but you know, you can, that's the beauty of the videos. You can pause them, you can go back and remind yourself of where I got those numbers that you were looking for. I just pulled the numbers that I did originally over. So if you got a big sheet of paper, you'll have them where you can look back and forth at them, but with these, I just have to do it. And I could do these all on one page and everything, but you know, I just wanted to spread out a little bit so you could see each step and understand where these numbers were coming from and exactly what I was doing. Okay, so you just need to know what the units are, what you do. Mole fraction is moles divided by total moles, and mole percent is that times 100. That one's pretty easy, right? Percent by mass is grams of the solute divided by total grams, solute plus solvent. Molarity is how many moles of solute per liter of solution. That's why I used this number, because it's the total volume. And molality is moles per kilograms, and that's why I gave you kilograms of water. Or, yeah, kilograms of water. So I gave you some practice. So these are very similar to what I just did. It gives you all these same numbers, and you should be able to pull those numbers out and go through those calculations and practice doing this, because you might see on an exam, you know, calculate the percent by mass and give you the numbers, or what is the mole percent and give you the numbers. So they may not be like in a row like this, but it's good to practice them that way, and that way you can kind of figure out what you're doing. All right, so that is calculating concentrations in all kinds of different fun and new ways.